Okay, so on Group E problems, we're talking about trapezoid stuff. Speaking of a trapezoid, it is a four-sided shape, which makes it a quadrilateral, and its special property is that it has two opposite sides which are parallel to each other, and those two are called the bases. We usually label them with a B sub 1 and a B sub 2 there. Doesn't matter which one's which. And we have two other sides here, often referred to as the legs, A and C. And those two cannot be parallel. If they were parallel, then the shape would turn into a parallelogram. Parallelogram, trapezoid, two different shapes. Didn't know if you knew that or not. Okay. It is possible that A and C, those two side lengths, are the same. If they are the same, this becomes a special trapezoid called an isosceles trapezoid. You've probably heard that word isosceles before, crammed in front of the word triangle. Anyway, we have also our height segment. It makes a right angle with both the bottom and the top, the two bases. That's perpendicular, right? Now, it's not marked up here that it makes a right angle, but it definitely does. It's still perpendicular to the other base. Okay, so if I take a look at both of my formula over here, our perimeter, nothing special is happening. It's just the sum of the sides. It just says A plus B1, so we're just adding these things up. A plus B1 plus B2 plus C, that's it. Our area formula, however, our area is equal to 1/2 the sum of the two bases multiplied times the height. Sometimes people write that out like this. The sum of the two bases multiplied times the height, and then all of that divided by 2. That's acceptable. All right, so let's look at the actual problem set for these three problems. Number 1, find the perimeter and the area of the trapezoid below. All right, and we have 3 little pieces labeled for us. That seems straightforward enough. It's probably not, though. Number 2, solve the trapezoid area formula for 1/2. Okay, we've done problems like that before. This one I think is going to be a little simpler because take a look. It already has a 1/2 in it. Great. Okay, and then finally, number 3, the area of a trapezoid is 7/12 inches squared. If the height of the trapezoid is 3/2 inches, what is the average length of its bases? Oh, average length of the bases. Well, I know average is the, like, you add two things together and then you divide it by 2. I don't know. I guess we'll see whenever we get to that problem. Let's go ahead and go over here to Notability so we can write on stuff. So number 1, finding the perimeter and the area of the trapezoid. I do have 3 sides that are labeled for me, and I do want to distinguish what side is what. So the top here and the bottom are the two bases, and I know that those are the two bases. I can see, I can use my eyeball to go, hey, those two things look like they're the parallel sides. Now, we will, in a future lesson further down the road, learn of a particular theorem in geometry which says if you have a line, in this case a line segment, which is perpendicular to 2 other lines, those 2 lines have to be parallel to each other, all right? And so they definitely are. Those are our 2 bases. This one that makes a right angle, this 10.6, that one has to be our height. And we do have a slight problem, and that's this slanty side over here. I have no idea what it is, and I need to know it in order to figure out the perimeter. Okay, kind of a hint here. If I take a look at this original picture, the purple one, notice that the height does make a little right triangle over here. Could be pretty handy. I'm going to do the same kind of thing over here. And since that one's purple, you know what? I'm going to go ahead and go with purple. Yep. So I'm going to drop down another height over here to make that right triangle. And I'm going to go ahead and color it in with my crayon, my purple crayon. There we go. And now I just need to figure out some pieces, some lengths of that right triangle so I can use the Pythagorean theorem on it. Well, one of them is pretty easy, and that is the height here, this 10.6. It's got to be the same 10.6 over here, so there's one piece I know. 10.6. Okay, I'm going to do the same kind of thing for the top and the bottom. Notice that the shape is, it's essentially a rectangle here, and then I have a rectangle that's squished to the side. So this 8.9, I can bring it straight down over here and say that part of this 13.7 is 8.9. And then we have a little bit that's left over, which is the other side length of the right triangle. That's what I want to get. So how do I get it? Well, does it make sense that these two pieces should add up to 13.7? So if I want the little side of that right triangle, I can just subtract these. Hey, let's pull open that calculator. I do have that Desmos calculator here. What the heck were the numbers? I don't know. I will open both of these so I can see them. I have a 13.7 as the longer one, and then I'm going to subtract from that 8.9. Excellent. And I have the 4.8. That's what it is. Okay, so now I have, whoops, that is not where that goes. It goes down here, 4.8. Now I need to use the Pythagorean theorem to find the slanted side, which I will call C. Obviously, there's just not enough room. Who makes these things? I'm going to scroll down here a little bit, maybe redraw my right triangle, and then label the little pieces that I have. I've got a 4.8 as the smaller side, a 10.6 for the longer leg, and then I want to find out the hypotenuse. So C squared is equal to, let's say, 4.8 squared plus 10.6 squared. Now, I could square these numbers out in the calculator, add them up, and all of that business, but here's another little strategy for you. I have a feeling that this is not going to be a nice, neat number when I'm all done. Like, it's going to be some weird decimal number, some irrational number. Since that's the case, I'm going to be using the calculator at the end of this anyway. So I'm going to just do all the math on the numbers and only put all of the numbers into the calculator at the very end. So in other words, I'm not going to work out 4.8 squared. I'm not going to work out 10.6 squared. It's all going to go into the calculator. And I'm just going to get C by itself by getting rid of the square. To undo a square, I'm going to take the square root of both sides. So let's take the square root of that side, take the square root of this side. On the left-hand side, they do cancel, they're inverses, and we ignore the negative answer because we're looking for a positive length here. And so I just have this weird quantity, the square root of 4.8 squared plus 10.6 squared. And again, I will just put that straight up in my calculator. Okay, all in one go. Square root button, and then we have a 4.8, which we are squaring, and then plus 10.6, which we are also squaring, and you can see the number popping up on the screen. So that number, the decimals just keep on going, as you can see, and there's no little fraction-y button over here at the end. All of those things kind of clue me into the fact that this is irrational. And the best I can hope for here is just a decimal approximation. So I'm going to just chop this off at, say, 3 decimal places and say that C is approximately equal to 11.636. Okay? Nope. Now I am finally ready. I'm going to get rid of this. 11.636. I'm finally ready to find the perimeter 4 hours later. So the perimeter is just simply the sum of all the pieces. Just add them up. Just careful, though, that we don't want to add these pieces and the 13.7. The 13.7, that's the one that we will use. Okay, so I've got a 13.7 plus a 10.6 plus an 8.9 plus this 11.636. Now, technically, since I have rounded this off, this is not the exact length of this hypotenuse over here. I'm going to get rid of this equal sign and put an approximately equal sign. All right? So now it is calculator time for sure. And I want to just add, of course I don't remember those numbers. I'm going to have to put this side by side again. So I'll type them in just so I can see them there. So I have 13.7 plus a 10.6. So what's next? Sure. And the 8.9, which is up top. And then instead of actually using the 11.636, which we chopped off, what I am going to do is I'm going to recall this number that is already on the screen. It's the last answer that's on the screen, and there's a button for that on the calculator. It's A and S. In order to access that, if you have one of those TI-84 calculators, I do believe it is second negative sign, because the little A and S button answer is right above the negative sign. So I can call that up, and notice it, like it even labels it for me there. And then I have that irrational number here, which again I'm going to have to approximate, and I will go ahead and do that to, let's say, 3 decimal places one more time. So since I have kind of run out of room, I'll just write it right down here. The perimeter is approximately equal to 44.836, I think. 36. And, of course, this is a perimeter. Each one of these lengths, it's not even indicated. So what am I supposed to use for a unit? That's right. Units. That's it. Just generic units. If something is not indicated, just use that word or the letter U. Perfectly acceptable. All right, then. I think that we are finally ready to find the area of this thing. Area formula, let's look back at that. I need the 2 bases, which I'm going to add up, multiply that times the height, multiply that whole thing times a half. All right, so we have, like we already knew the information that we needed for the area of this thing. We needed the 2 bases, which are the top and the bottom for this particular picture, and the height, which is that 10.6. All right, so I'll leave it like right about there so I can find its area. Area is equal to 1/2 sum of the 2 bases, 8.9 plus 13.7, and then multiply it times the height, which is 10.6. And we'll be good to go as soon as we throw all of this in the calculator. So I can use a fraction bar for the 1/2 if I wanted to, or you can put it in as 0.5. You know, it's up to you. That would not be acceptable, though. Okay, that's better. And then we can multiply that. I do have some parentheses here, which is nice. And 8.9 plus, whoops, that didn't give me the 0.9. There we go. Plus 13.7. I know how much you guys like to watch somebody just type numbers into the calculator. It's the best video ever. All right, and then multiply all of that by 10.6. And there we go. So we have, now this one is an exact answer. You can see the little fraction toggle switch over here. The decimals stop. When the decimals terminate like that, I could always write that thing as a fraction. It is a rational number. That's the exact answer there. So no need for an approximation symbol for this one. It is exactly equal to 119.78. And what units do I need to tag to the end of this? Since we don't know what the units are, we will just say it is units, which are squared, and then put an official box around that so I know what your answer is supposed to be. Right and right. Let's see how long this has been so far. I didn't start the timer. So I got a kind of feeling that this particular video is long enough, so we will pick up number 2 and 3 in the next one.